Okay, Assalamualaikum and a very good morning, students. So we're going to have our lecture today and continue with our topics, which is integration 2, right? We have 3 parts of integrations all together, and today we're going to have a look on integration 2, right? So for your information, I think I prefer our class to go like this, which is a pre-recorded lecture where you can always watch this video, and then during my class time, which is from Wednesday from 11 to 1, right? And then you can replay the video if you don't understand and then want to do some revision on this topic. Okay, so now student, let's continue. All right. Okay, so as you can see here, okay, today our topic will cover on substitution rule, and then the fundamental of theorem of calculus, and also integration by parts. All right. So what is the substitution method, students? Okay, as you can see, substitution is actually running the chain rule backwards, right? If you remember, chain rules from the derivatives, our topic derivatives, and also differentiation, right? As you can see here, if u is a differentiable function of x and n is any number different from -1, so chain rule tells us that dy over dx is equals to dy over du times du over dx, right? So d over dx u to the power of n plus 1 divided by n plus 1 is equals to u to the power of n du dx. Hence, the integral of u to the power of n du over dx is actually u to the power of n plus 1 divided by n plus 1 plus c. Okay, so to put it simpler, all right, so the integral of u to the power of n du is equals to u to the power of n plus 1 divided by n plus 1 plus c. Okay, so now which suggests that the simple expression du can be substituted for du over dx when computing an integral. As with differentials, when computing the integrals, we will have, right, du equals to du over dx. Okay, you will see that this makes sense on the next example. Okay, as you can see here, as an example, find the integral of x cubed plus x to the power of 5 times 3x squared plus 1 dx, right? So now if you see it properly, so this is actually, right, the integral of inside here, right? Okay, so for example, let u is equals to x squared plus x, all right, and you will be du is equals to d over dx, which is actually 3x squared plus 1. Okay, so you just substitute it into the original function, right? This one as u and this one as du, and you will get u to the power of 5 du. So this is simpler for you to complete, or for you to do a solution, to find a solution. So it's equals to u to the power of 6 over 6 plus c, and integrate with respect to u. Okay, and then you don't forget to substitute it back u into the original function. Okay, so next, find the integral of 2x plus 1 and square root of tx plus 1 dx. So using the formula of the original one, u to the power of n du, so we let u is equals to 2x plus 1 and n is equals to half, then du is equals to dx, du over dx is equals to 2. So now dx is equals to half du, right? Because you want to substitute the dx here, right? So now we substitute it all into the original function, and you'll get square root of u times half times du, right? Because ds is half du. Okay, so now you take it out half because it is constant, times integral of square root u du, right? And then you will get you will get half u to the power of 3 over 2 over 3 over 2 plus c when you integrate with respect to u, right? So you will rearrange it properly here. You'll get 1 over 3 u to the power of 3 over 2 plus c. Don't forget to substitute it back to the original u. So you'll get this answer, all right? And this is quite easy for you, I guess. So as a theorem, okay, the substitution rule is if u is equals to gx is a differentiable function whose range is an interval I and f is a continuous on I, then the integral of f, the function f gx g prime x dx is equals to fu du. Okay. So this is another example where there's a two solution that you can do. Okay. As you can see here, the first one, so this is the function 2x over x squared plus 1 to the power of 1 over 3 lah, right? And for the solution one, okay, this one, it let the u is equal to x squared plus 1, right? Then it will get du is equal to 2x dx. So substitute it together inside here and you get the answer of 3 over 2 u to the power of 2 over 3 plus c. And then don't forget to substitute it back into the original equation. I mean original function, because you want to get the answer is in x, not in u. Okay. Another solution is it let the u is equals to this whole thing. Right? Yes, you can definitely do it, complete it. Right? Find the solution from this as u cube is equals to x squared plus 1 and 3u squared du is equals to 2x dx. So you substitute it all together and then you will get this one, this answer 3 u to the power of 2 over 2 plus c. So don't forget to substitute it back. At the end of the day, you'll get the same answer from solution 1 and solution 2. So both way is correct. All right. So now, as you can see here, okay, this is the substitution method on using the sine and cos, where we will going to use the trigonometric identities to transform the integral into a simpler form by using substitution rule for the ease of evaluation, right? Right, for example, how to find the sine squared x dx, okay? It's quite difficult to find, right? So now, using the trigonometric identities, right, you just substitute with sine squared x, which is actually equals to 1 minus cos 2x over 2 dx. Okay, after you substitute it, and then you can integrate it normally, right, using the formula where cos x, okay, is equals to cos x is equals to sin x. All right. If you don't remember this, please refer to slide 9 or previous slide on integration 1. All right, and you can actually manage to integrate this. Okay. And you get the answer of x over 2 minus sine 2x over 4 plus c. Okay, similar to cos squared x dx, right? Just substitute it, cos squared x is equals to 1 plus cos 2x over 2. Okay, and then this is also equals to half 1 plus cos 2x. So integrate the 1 plus cos 2x, you'll get x plus half sine 2x plus c. And this is the final answer. Okay. Sorry. So this is an example of the substitution method. I will show you some of the solution from A to D. And students, I would like you to complete E. Okay, and send me as a quiz after this lecture. Okay. All right. as you can see here, all right, tangent x is equals to sine x over cos x dx. Okay, where do you find tangent x equals to sine x cos x over cos x? Is in trigonometric identities. Usually, if you sit for an exam or test, we will give you the formula of the trigonometric identities, so you don't have to memorize it. However, you need to know how to calculate, how to find the answer or using the trigonometric identities, right? So in this case, we let u is equals to cos x, and then you will get du is equals to negative sine x dx. Okay, so because it will be easier for you to have negative there, so sine x dx is equals to negative du. Okay, so now just substitute it as negative 1 over u du. Okay, so integrate the 1 over u du, you will get negative ln u plus c. Then you substitute it back u as cos x, you will get negative ln cos x plus c. Okay, but remember students, sometimes students just leave the answer as it is, which is negative ln cos x plus c. But actually, it hasn't finished yet, because negative ln cos x means ln cos x to the power of negative 1 plus c, alright? Which is actually ln 1 over cos x. And 1 over cos x is secant x. So the final answer will be the integration of tangent x is ln sec s plus c. Okay? So now we have a look at the second example here, which is the secant y dy. Alright? In this case, okay, why we add secant y plus tangent y? Okay, this is because this is quite special, right? You can also find the integration of cosecant y by using this method. Okay, so now we add, not add now, we introduce the secant y plus tangent y over secant y plus tangent y here, so that because if we cancel this, we will get 1, right? If you cancel this, you get 1. So now just add this one, secant y plus tangent y divided by secant y plus tangent y times secant y over 1. Okay, then you will get secant squared y plus tangent y secant y over secant y plus tangent y dy. Why do we substitute it? Why we do it like this? Because we want to have a substitution for u. For example, if we let u is equals to secant y plus tangent y, du is equals to secant y tangent y plus secant squared y dy. Alright? Now, you substitute it inside here, you will get 1 over u du, which is very much simpler for you to find the solution, which is equals to ln u plus c. And at the end of the day, you just substitute u as secant y plus tangent y, and you get ln secant y plus tangent y plus c. Okay, try to take some time and complete it using cosecant y, right, student? Another example is cos square root of x over square root of x. I guess this one is quite easy for you, where you just substitute u as x square root of x, or x to the power of half. Then you get du is equals to half x to the power of negative half dx, and then 2 du is equals to x to the power of negative half dx. Then substitute it as usual, where 2, you take it out 2 here, so you just 2 times integration of cos u du, and you'll get 2 sine u plus c. Okay, don't forget to substitute u back, you'll get 2 sine square root of x plus c. Okay. And last one is integration, integration of e to the power of t plus e to the power of t dt. Alright. Now usually student will let u is equals to t to the power of et, right? T to the power of e to the power of t, and then du is 1 plus e to the power of t du. So we cannot use this because this is not the same, right? So it will stop. So how we need to do this is we need to rewrite the integrand. For example, here e to the power of t plus e to the power of t is actually e to the power of t times e to the power of e to the power of t dt. Alright? Okay? I hope you get this, right? So now use the substitution as u is equals to e to the power of t. Hence, du is equals to e to the power of t dt. So now we have the integration of e to the power of t times e to the power of e to the power of t is actually equals to u du, which is very simple for you to complete this, right? As e to the power of u plus c. So don't forget to substitute back u as e to the power of t plus c. Okay, as you can see here, e to the power of t plus e to the power of t, if it is minus, you need to divide. Alright, this is because it is plus, it's actually a multiply. Right, so okay, so this is the example of for the first exercise or examples. Alright, so students please complete one. Okay, this is example 1. Okay, please complete example 1e. All right, and then give me at the end of this lecture. Okay. Okay, moving on, student. We want to have a look in the substitution rule in definite integrals. Right? It means that it's just same as before, but we have the limit here. Right? We have the range here. Right? So if g prime is continuous on the interval a, b, and f is continuous on the range of gs equals to u, then okay, the integration will be right. The new range is actually will take the new limit lah, which means you need to substitute it. When you substitute it, you substitute the function. Don't forget to substitute the new range. Alright. How to do this? Okay, this is the example for integration of -1 to 1 for 3 to 3x squared and times square root of x cubed plus 1 dx. Okay, as a solution 1, right, in this case it let u is equals to x cubed plus 1, so du is equals to 3x squared dx. So don't forget, here is not the same anymore. Okay, the range is not the same anymore, so you need to substitute it the range as well, which means you take x is equals to -1 in u, and you'll get u is equals to -1 cube plus 1, which is equals to 0. And when x is equals to 1, right, substitute it here and you will get 1 plus 1, which is equals to u. So your new range will be from 0 to 2. Okay, then you complete it as normal integration of square root of u du. You'll get 2 over 3 u to the power of 3 over 2, and then put the range or the limit inside, and then at the end of the day you'll get 4 over 4 square root of 2 times 3. Okay, if you use calculator you get the point numbers, so it's just the same, right? So as a solution 2, okay, example here, right, in this case, right, it's actually complete the integration substitute method first plus c, and then inside here it puts the range or the limit. Okay, and then when it put it inside here, it will get the same answer. So either you find a new range or new limit, and then you get the answer, and you complete the integration first, and then you put the range, you will still get the same answer. Okay, but personally for me, I just don't like this C. Okay, so I usually find the new limit or new range if when I'm going to use the substitution method. Okay, it's up to you. Okay, so which one do you want to use? Okay, so for the exercise, example here. Okay, let me change this first. Okay. Alright, as for the example here, alright, as 2a, okay, the substitution and convert for the example first, from negative 1 to 5, 1 plus w times 2w plus w squared to the power of 5 dw. So the substitution and converted limits are here. You put u is equals to 2w plus w squared, alright. Okay. As for the next example, okay,